Compute the hydrostatic force and its line of action on semi-cylindrical bulge ABC. The bulge is 1.8 meters into the screen. So this is the given figure. Take note, this is semi-cylindrical bulge, not hemispherical. So for the horizontal force, we draw lines to the endpoints of the curve, so which is A and C, but this is cylindrical, so therefore it is 1.8 meters into the screen. Its projection would be 1.6 high and rectangular in shape at 1.8 meters wide. So FH acts below the centroid of this area, and it is equal to specific weight barred H area. Specific weight of water, barred H area. FV on the other hand is, because the principle is we draw lines, so this is straight line through A and C to the liquid surface here, and they are aligned, so the vertical component of the force is equal to the weight of imaginary liquid bounded by those vertical lines up to the liquid surface, up to the water surface, the curve itself. So therefore, the volume to be considered is the volume of this semi-cylindrical bulge. So therefore, the force FV passes through the centroid of this semicircle, which is 4r over 3 pi from this vertical line here. So call that E sub V, FV, and let's call that X sub C. X sub C is 4r over 3 pi. So FH is specific weight of water, barred H is 0.4 plus 1.8 plus 1.6 over 2 to reach the centroid of this projected area. And after that barred H, the area is 1.8 by 1.6. So FH is 84.76 kilonewtons. FV on the other hand is specific weight of water times volume of this semi-cylindrical bulge, which is area of semicircle, times length perpendicular to the board, which is 1.8. So FV is 9.81, quantity pi over 2 or 0.5 pi over 2 radius of the semi-cylindrical bulge, which is 0.8, half of 1.6. So radius square times with length perpendicular to the screen, 1.8. So FV is equal to 17.75 kilonewtons. Then the resultant, let's solve for E sub V, which is height of rectangle 1.6 square over 12 barred H. So 1.6 square over 12 times quantity 0.4 plus 1 plus 1.6 over 2. So E sub V is 0.0711 meters. So FH is below B by this value. Then X sub C is 4R, 4 times 0.8 over 3 pi. It is equal to 0.3395 meters. But because this is circular, by principle, the resultant force passes through O at an angle of arctan of FV over FH. So that's F. The resultant force is square root of 84.76 square plus 17.75 square. So this should be specified because its line of action is clearly passing through point O. So F is equal to 86.6 kilonewtons through O up to the right through an angle of theta arctan of FV 17.75 over FH 84.76 or 11.83 degrees. So this theta here is 11.83 degrees up to the right. So that's it.